Hello, good morning dear students. We are almost to the last topics of this chapter. Not exactly the last topic, but almost to the last topic of the chapter. So here we are going to discuss force acting in a moving charge in a magnetic field. There is a difference in the discussion, isn't it? Until now we discussed force acting on a straight current carrying conductor, circular current carrying coil or solenoid. That's all conductors. And in the last case we considered the force acting on a current carrying conductor in a magnetic field, isn't it? But now here we are considering force acting on a moving charge. We know moving charges or the ordered flow of charges produce electric current, isn't it? That is the definition for electric current. Ordered flow of charges or the flow of charges per unit time. That is the definition for electric current. So in the last topic we already discussed force acting on a conductor in a magnetic field. In that case we derived an equation for the force F directly proportional to ILB, and we reached at the equation F equal to ILB. Don't you remember the same equation, ILB? So in the case of a moving charge is actually inside of this current carrying conductor, isn't it? It is present inside of current carrying conductor. So here when we are considering charge, instead of this current we'll replace this equation by the equation for charge. We know I is equal to, what is the equation of current? I is equal to Q by T, isn't it? This is the equation for electric current. Let us replace this I by using Q by T, as we are considering moving charge, not the current carrying conductor we are considering here. So let us replace this I by Q by T. Q divided by T into L into B. Now let me replace the equation as F equal to Q into L by T. So I rearranged the equation as I brought this T into the bottom of L. There is no problem. We can bring it to anywhere else because it's all divided by T. Okay, fine. L by T. What is length by time or distance by time? You studied in the very first chapter of 9th class. Distance by time. What is it? Yes, Q into V into B. What is V? Distance by time is the speed or velocity. So we got the equation F equal to Q V B. As we are considering one charge only, we can write this Q as small letter q. F equal to Q into VB. Why we write so? This is the generalized equation for charge as we are considering one moving charge, a moving charge. As we are considering a moving charge only, we can write the equation F equal to QVB, where Q is the charge of a single electron or charge of whatever body present there. V is the velocity by which it is moving in the conductor, and B is the magnetic field present there. Hope it is clear. F equal to the force, Q equal to charge of individual particle, V is equal to velocity of the moving charge, and B is the magnitude of magnetic field present there. See now, so we discussed the equation for magnitude of force. Now we are going to discuss of this direction of this force. How can we find direction of force? In the last case we find the direction of force by using a law, using a rule, Fleming's left hand rule. The same thing is used here. So we can find the direction of moving charge by using Fleming's left hand rule. So by using that equation we can find the direction of this moving charge. What was Fleming's left hand rule? We have to stretch our left hand as such. Forefinger, middle finger and thumb are mutually perpendicular to each other. Then forefinger will show us the magnetic field, direction of magnetic field. Middle finger or central finger will show us the direction of current. Thumb finger will show us the direction of force. So the direction of force is given by Fleming's left hand rule. Now we know there are two types of charges. What are they? Positive charge and negative charge. So positive charge and negative charge will be differed in their directions also. They will be opposite. So the force acting on the negative charge will be opposite to the force acting on the positive charge. This is just a point to remember. In this case of force acting on a moving charge in a magnetic field. It's a very short topic. You just have to know the equation F equal to ILB, and from that equation we can easily derive this equation F equal to QVB, which is very important equation, and this will be asked even in the multiple choice also, because 1 year it's already asked. This question was repeated for 2 years, I think. The force acting on a moving charge in a magnetic field is, and there will be 4 options. So you have to take QVB. You have to take the answer with the QVB, where Q is the charge, V is the velocity, and B is the magnitude of magnetic field. Hope this section is clear. It's very easy topic. Thank you for watching, and if you have any doubt in this section also, you can contact me. Thank you.